All right, so when we don't have a linear relationship, we have to linearize it. So when we have a linear relationship, in this case we do, what we really have graphed here is a proportionality, a direct proportionality that y is directly proportional or proportional to x. So if we graphed y and x, like this is a set of data, we would get a linear relationship. How about over here? We don't have a linear relationship because y is not proportional to x. With this type of graph, it has its own form of an equation. Just like this graph over here has a form of the equation y equals mx plus b. Well, this equation is going to be y is equal to a, some other constant other than a slope, because this doesn't have a slope, x squared. So that y is proportional to x squared. So that if I doubled the x value, the y value, so if I double the x value, the y value would increase by 4. All right, so graphing y and x directly will not give us a linear relationship. If we graphed y and x squared, we would have a linear relationship. The equation for this type of shape is y is equal to a, some constant, over x. So that if we graph y and x like this, we don't get a linear relationship because y is proportional to 1 over x. So if we put y on the y-axis and 1 over x here, we would then get a linear relationship. Over here, we have y is equal to a times the square root of x. So that y is proportional to the square root of x. Now, it's not an equation, but it is proportional. It's not an equation because there's other factors that are involved. This is the equation, hence the equal sign. This is a proportionality. It does not include this other factor into those equations, okay, that the equations have. The proportionalities omit the specifics. But you can still do math on a proportionality. So I would be hesitant to ever put a square root of a value onto an axis. You can always just do the math here and square both sides so that y squared is proportional to x. And this is what I would put on my next graph to linearize it. I would have y squared and x, and then you get a linear relationship. So if we look at an equation that we should be somewhat familiar with, that kinetic energy is equal to 1/2 mv squared. So if we plotted kinetic energy and velocity onto our x and y axes, if we compare it to this, okay, you can see here that y would correspond with k, a would correspond with 1/2 the mass, and then v would correspond with x. So if we graph y and x, we get a curve. If we graph k and v, we get a curve. In order to linearize this, k is proportional to v squared. So I would have to make a new graph that has k on that axis and v squared on this axis. Then if I graph that, I have a linear relationship, and the slope here is going to be equal to 1/2 of the mass. We can pick any equation off of our equation sheet, and we would have that same type of Let's look at another equation. Let's look at our universal law of gravitation here. So if we made a graph, or took data, plotted that data, so that we put the force and distance, what we would have is that type of relationship. So knowing the relationship, or just knowing that is, what does that look like, we can see that the force is proportional to 1 over r. We definitely know it's an inverse, okay? So if we know the equation, we know that it's going to be proportional 1 over r squared. If we don't know the equation, we actually have to take a look at different data points and see how the values change. So if I halved the force, how much did the distance change? And we would figure out that there would be a squared relationship. So in order to linearize this proportionality tells me what to put on each axis. So I would have to put force and 1 over r squared on the axes. And if I took all those original data points that gave me this plot, and I took those r values, I did 1 over that value squared for all of them and replotted, it would give me a linear relationship. We did this graph in honors physics for the electric field. So we can find out the proportionality between E and R. E was proportional to 1 over r squared. Very similar type of linearization there. So most of the AP level problems that require you to make a graph will have you either linearize that data or make sure you can write the equation from the graph and figure out what the slope means, which is what the previous video went through. So at least this gives you a starting point, something to think about for your summer assignment. Make sure that you, if you're having problems with this, try to look out on the internet for some other resources that may help it make a little bit more sense to you. Okay, this is going to be vital for your success in AP Physics.